All right, this is our last example of elimination for today. And we're going to do the same process that we just saw in the previous two examples, where our goal is to match up two pairs of equations, get rid of one of the variables, so that way we can work with the remaining two variables in a two-variable system. So let's go ahead and tackle this last example. And let's begin by considering which variable value is going to be the easiest to cancel. For our x terms, we have coefficients of 1, 3, and 2. For y, we've got a -1, a +1, and a 4. And for z, we've got a 3, a -2, and a 1. My recommendation here would be to go ahead and cancel out your y's using elimination. The reason why I think that's useful to do here is because your y's are already a -1 and a +1 in the first two equations. So they're going to be pretty easy to cancel out together. So let's label our equations A, B, and C. And then let's get started by combining A and B. And my goal here is going to be to cancel out the y's. So I have x minus y plus 3z is equal to 8. And then in my next equation down, 3x plus y minus 2z is equal to -2. Now the y's are opposite values of one another, so I'm going to go ahead and add in order to get them to cancel out. So when I do that, I'll end up with x plus 3x giving me 4x, -y plus y, those will cancel out, and then 3z plus -2z, that's going to give me just 1 plus z, and 8 plus -2, that's going to give me +6. So then I've got an equation that just has x and z all by themselves. So then I want to pick another set of equations to work with, and I'm going to go ahead and combine equations b and c next. The reason why I'm going to stick with b and c here instead of equations a and c is that I think it's easier to work with a +1 and a +4 instead of a -1 and a +4 for the coefficients. That way I don't have to worry about changes in signs to cancel out. So the equations that we have for b and c, b is 3x plus y minus 2z is equal to -2, and c is 2x plus 4y plus z is equal to 0. So if I want my y's to cancel out, I need to multiply my entire top equation by 4. If I do that, then I'll have a 4y that I can get to go away. So 4 times 3x is going to become 12x. 4 times y will give me 4y. 4 times -2z gives me -8z. And 4 times -2 gives me -8. Then I can just copy down the second equation directly. So 2x plus 4y plus z is equal to 0. At this point, we're good to go ahead and use our elimination. And we're going to subtract here since they're the same sign to get the 4y's to go away. So when I do that, 12x minus 2x is going to become positive 10x. Those will cancel out, or those will go to 10x, and then the 4y's will cancel out. Then we'll have minus 8z minus another z. So we'll have minus 9z there. And then we'll have -8 minus 0 is going to be -8 over on this right-hand side. So those are going to be the two equations with x and z that we want to work with. So let's go ahead and copy those down so that way we can decide the best way to solve them moving forward. 4x plus z equals 6. 10x minus 9z equals -8. For these, it's up to you what you would want to do to make things cancel out. It would be pretty easy to use substitution, getting the z value by itself and plugging into the next equation. Also though, using elimination again isn't going to be that bad, because if I multiply everything by 9, I can get things to cancel. Because we're doing so much elimination practice here, I'm just going to go with elimination again, and I'll multiply all of my top values by 9. So this will become 36x This will become 9z, and then this 6, if I multiply that value by 9, is going to become 54. So took care of all of those, and now I can combine the top equation with this one down below. I'm going to go ahead and add, so that way the positive 9 and the negative 9 will cancel out. Now over on the left-hand side, 36x plus positive 10x, that's going to give me 46x. The 9z's plus negative 9, that goes away. And then 54 plus negative 8, so 54 minus 8 is going to give me 46 over here. So I divide by 46, and the nice thing here is that my x value just becomes 1. I always like it when things work out to be a 1 or a 2. Those are easy to work with. So let's take that x value that we found, and let's plug it back in here to solve for z. So we'll have 4 times 1 plus z is equal to 6. 4 plus z is equal to 6. And then if I subtract 4 from both sides, my z value is going to be equal to 2. So another one of those nice results. Very last thing I need to do is to solve for a y, and I can just pick any one of my original equations to plug back into. I think I prefer b because once again, I just have that one y in there, so it's going to be easy to get by itself. So let's go ahead and plug in our x and our z values. So 3 times x is going to be 3 times 1 plus the y value minus 2z, so minus 2 times 2 is equal to negative 2. So this will become 3 plus y minus 4 equals negative 2. 3 minus 4, that's going to give me minus 1 equals negative 2. And then if I add 1 to both sides, I'm running out of room. But negative 2 plus 1, my y is going to become, oops, there should be a negative in front there. So this is going to become negative 1. So make sure that negative's right there. What I want to do next is to write my solution as an ordered triple. So my x value is 1, my y value is negative 1, my z value is 2. So that's going to be my final answer for my ordered triple there. One last point that I want to emphasize to you guys for these types of problems is that there are many correct ways to go about trying to do them. I could combine equations A and B to get started and B and C, or I could have done A and C and B and C. So I've got different methods that I can start off with. Then I always have the choice once I get to my two variable equations, so once I get to this point, I can decide to use substitution or elimination. Either approach would be fine. Once I get my variable values and start back substituting them in to find out what's missing, I also have options to choose which equation I want to plug back in. So please don't assume that there's always one right pathway forward for these kinds of problems. You really want to decide based off of the equation whether you think elimination or substitution is easier. Then when you get to two variables, once again, consider which process is a little bit easier. And then once you get a variable value, just think, what other equations do I have where I can get from one value, then to two values, and from two values back to that final third value. So please use the remaining class time to get started on your homework for tonight. You've got 4 elimination practice problems, and then you can use whatever other time you need if there's any problems you need to wrap up from last night. If there are some from last night that are feeling tricky with substitution, you might want to try them getting started with elimination and then go back and practice with the substitution, just so you feel like you can tackle any scenario using either of the techniques. So we'll practice this some more tomorrow, and we'll also take a look at a few more examples of 3 variable systems. So please email me if you have any questions. Otherwise, I'll see you guys tomorrow in class.